This is NMSU's 2020 Smart Robot Bed Capstone project. The objective of this project was to develop robotic beds and arms that would be useful to healthcare professionals and patients. The United States is simultaneously experiencing a shortage of healthcare workers and an influx of patients that need regular long-term care, especially as the population ages. The New Mexico Department of Workforce Solutions projects healthcare and social assistance employment will grow 23.2% in the state of New Mexico from 2014 to 2024, composing more than 40% of all employment growth in the state during the same period. New Mexico's healthcare workforce is characterized by shortages already. The New Mexico Healthcare Workforce Committee report indicated that Doña Ana County alone would need an additional 363 registered nurses to meet national benchmarks in 2019. With these challenges in mind, these designs are intended to work towards resolving several concerns. First, reduce the physical burden on caregivers, as lifting, moving, and supporting patients can lead to workplace injury, exhaustion, and chronic pain. Reduce the stress and time pressure on caregivers, increasing retention. Increase the number of patients that a nurse can reasonably care for. Better the quality of life of patients by increasing their comfort and independence. And especially in the wake of recent epidemiological events, work to ensure that elder and other daily care is not allowed to fall below a minimum acceptable threshold when patients need to isolate for their own safety, or when caregivers are spread thin or pulled away in an emergency. The first design is a bed with moving panels that can fold towards the center to assist an occupant in turning over, regularly change their position to reduce discomfort in bed, and support them on their side. This design can be combined with a linear arm, which can also provide support while leaving caregivers hands-free to change clothes or bedding. The occupant or nurse could be given control of the bed's orientation to suit their needs, or the bed could be configured to adjust in regular intervals. The second design is a treadmill-style bed composed of multiple shafts that can be oriented for different tasks. By positioning the bed in a U formation, the occupant can be safely rolled over in either direction. The outermost shafts can be raised to provide safety bumpers, or the head and feet can be raised respectively. Similarly, this bed can be combined with an angular arm, which can provide support to the resting patient, or be used to assist with sitting or standing. This bed could also be configured for active control or passive adjustments. These designs employ linear and pinion gears to convert rotational motion and actuate the beds and arms. Several initial ideas were roughly generated through brainstorming and hand drawings, then further developed using CAD software and 3D animation. To investigate these concepts, scale models were created using 3D printing and hand construction, then combined with Arduino controllers and servo motors to test.